Hey folks, welcome to lesson 8. In this lesson we are going to learn some Excel functions that you didn't learn before, which deals with the nominal and effective interest rate. Okay, and this is basically based on chapter number 4. So there are two more Excel functions that we are going to use in this particular lesson or this chapter. One is effect, another is nominal. So basically you are going to find out the effective interest rate and the nominal interest rate based on the interest rates that is given to us. So in this particular case, you can see the effect deals with the nominal interest rate and number of compounding period, whereas the nominal interest rate is basically the effective interest rate when it is given to you and the compounding frequency per year. So let's do a problem, then you are going to understand what I'm talking about. So let's do this problem. Dave is planning to accept the offer for the Chase Bank credit card that carries an annual percentage rate, that means the nominal rate, of 14.24% per year or 1.187% per month. He will transfer the balance of $1,000 and plans to pay it and the transfer fee of $30 due at the end of the first month. Let's assume that Dave makes the transfer and only days later his employer has a 1-year assignment for him in the country of the Cameroon in northwestern Africa. Dave accepts the employment offer and in his hurried, excited departure, he forgets to send the credit card service company a change of address. Since he is now out of the mail touch, he does not pay his monthly balance due, which is calculated on the previous example, if you're in your book, example 4.2, to be 1041.87. Okay. If this situation continues for a total of 12 months, determine the total due after 12 months and the effective annual rate of interest Dave has accumulated. Remember, the fine print on the card's interest and fee information states a penalty of APR of 29.99% per year after one late payment of the minimum payment amount, plus a late payment fee of $39 per occurrence. If there were no penalty APR and no late fee, what is the effective annual interest rate would be charged for this year? Compare this rate with the answer in part A. So let's open the Excel first and then go from there. So first let's set up the Excel, okay, for this particular problem. First of all, there are 12 months because he is 1 year away from home. Okay, let's say this is month, which is basically starting from 0, 1 up to 12. Okay, then amount of credit. Then interest, monthly interest. Then the fees, because remember, if you miss one payment, there will be a late fee added to that, $30 late fee, and then finally amount due. So let me make it in the middle. So first of all, Dave took the amount of credit is $1,000. Okay. Now, what are the other information that is given to us? The interest rates, right? Okay. So let me just put per year and per month, because in credit cards the compounding period will be basically for 12 months. Okay, so first of all, the interest rate here he is being charged on is, let me just make those in interest rate. So the 14.24%. okay, that's the regular interest rate. And with the penalty, if you do not pay, the penalty will be 29.99. Okay, So what will be the per month interest rate? It will be nothing but this divided by 12, which is and then same right here. Alright. Now amount of credit for the year number month number 1. So at the second month the interest rate will be charged, right? So there is no interest at the first. That means when you borrow the money, when they borrowed the money, there will be no fee for that. There will be due at the beginning is basically $1,000. Let me make it add number. So in second month when the payment is due, okay, this is the amount. Now the interest will be charged based on the amount, okay, times the interest rate, which is in this case per month. So this is the part we are not going to use this one, okay, which is 11.87. Now there is a balance transfer fee at the end of first month because it is being charged at the very beginning. So there will be $30. So the total amount will be due at the end of month 1 is basically sum of these. Okay, so that's basically the amount due. Now as they miss the payments, what's going to happen? This is the amount of credit is due, so I'm going to use this cell. Okay, so put it there. Then the monthly interest will be charged now as he missed the payment. The moment he misses the payment, the interest rate will be the penalty interest rate, which is 29.99. That means per month it will be 2.4992. Okay, so the interest rate will be charged equal to this amount times this. Now I'm going to fix that cell because I'm going to use for throughout the whole time. Okay, so this will be the interest rate. Now the late fee will be added, which is $39. So the total amount due at the end of month 2 is this. Alright, now what I'm going to do, as I have all the equations set in the cells, I can just really bring it down up to 12 months, and that's basically my answer. I did a little mistake where. Oh, see that when I did that, as when I am going to select the cell, so this is another thing you like to actually see that. If I basically drag one cell down like that, it will automatically calculate that. But when I am dragging the 3 or 4 cell which has the equation added to it, see that it should be charged $39 every month. But what happened? When I selected all of them, it increased one at a time. So I need to fix that one. So if I fix this, see that this will be basically the total charge at the end of month 12. Okay, so this is how you're going to calculate this part. Alright, so let me just rename this. Hope you understand this part. Example. Alright, let's open another sheet. Let's go to the next problem. So in our continuing credit card saga of David and his job transfer to Africa, let's assume he did remember that the total transfer balance was $1,030 and $30 transfer fee, including the $30 transfer fee. And he wants to set up a monthly automatic checking account transfer to pay off the entire amount in 2 years. Once he learned that the minimum payment is $25 per month, Dave decided to be sure the monthly transfer exceeds this amount to avoid the further penalty fees, and the penalty APR is $29.99 per year. What amount should he ask to be transferred by the due date each month, and why the APY he will pay if the plan is followed exactly and the Chase Bank does not change the APR during the 2-year period? Also assume he left the credit card at home and will charge no more to it. Okay, so let's open the Excel again and go one at a time. Okay, so first of all, he is going to pay off a 2-year period. So every month he will be paying. So I'm going to basically, we need to find the total number of period as he will be paying monthly. Is in this case n equal to what? 2 times 12, 2 years and 12 months, which is 24. So I need to put an equal sign, otherwise this equation will not work. Alright, 24. Then the payment period and the compounding period is 1 month. So PP equal to CP equal to 1. I'm going to put month. Okay, this is also in month. Alright, so the monthly rate will be I equal to what is given to us is, put in the number, I is 14.24. Okay, so see this problem that I did. So this is yearly. Okay, so the monthly compounding interest, so this is in month. So let's put it right there. So equal to, we already did that on the previous example, which is this part. Okay, now it is showing in decimal, so month. Alright, so now how we are going to decide if he is not going to miss any payment? Okay, so we are going to use the PMT function to find what will be the payment amount. So equal to PMT. So then the rate is per month. We're going to select that, number of period 24, and the total present value that is borrowed with the balance transfer fee 1030. Okay, we do not need anything else. So this is basically $49.57 he has to pay every month. Okay, so that's basically the idea. Just for example, this is 4. Alright, now another thing I would like to add in this particular case. Okay, what is the effective interest rate that is happening, that he is paying? Okay, so if we use the effective equation, effective interest rate, effect, in this case the nominal rate is 14.24. okay, number of compounding period is 12 months. Okay, if I do that, see, this is the interest rate he is paying. So we can basically use the effective interest rate to find out how much more he is paying, though this is the APR. Okay, so that's another thing. Okay, so we can find the nominal interest rate using this equation. So equal to nominal, in this case the effective rate is that, and number of periods is 12, which is basically 14.24. So this is basically, I'm going to write down effective. And this is nominal. Okay, so if you are going to buy a car or finance a house or finance something, let's say you're buying some furniture for your dorm in interest rate payment, okay, or in financing, you can basically calculate your own interest rate. You can see how much they are charging per month or per day, a day, or so on and so forth, even for your credit card if you have a credit card. Alright, so let's do another problem. Alright, so this problem says the Scott and White health plan has purchased a robotized prescription fulfillment system for faster and more accurate delivery to patients with stable pill form medication for chronic health problems, such as diabetes, thyroid, and high blood pressure. Assume this high volume system costs $3 million to install and an estimated $200,000 per year for all material, operating, personnel, and maintenance cost. The expected life is 10 years and SWHP biomedical engineer wants to estimate the total revenue requirement for each 6-month period that is necessary to recover the investment, interest and annual cost. Find the semi-annual A value both by hand and by spreadsheet. We are not going to do it by hand, just by spreadsheet. If the capital funds are evaluated 8% per year using two different compounding periods. Number 1, 8% per year compounded semi-annually, 8% per year compounded monthly. So let's open the Excel and then see what we are going to do in this particular case. So first of all, let's set up everything. Alright. So first of all, the nominal interest rate is given to us. Nominal per year. So rate 1, which is 8%. So let me make it percentage cell. 2, this is also 8%. Okay, let me write it down. The compounding period is semi-annual in this case. And this is month. Alright, so number of period, the N in this case, for this case is 20. This is also 20. Where did 20 come from? Expected life of 10 years. Alright, so this is basically 10 years means 2 semi-annual period 20, and for the month this is also 20. Why is that? If you look at the problem statement again, it says where is that? An SWHP biomedical engineer wants to estimate the total revenue requirement for each 6-month period. So every semi-annual period. Okay, the monthly is basically being compounded, compounding period for the interest rate. So there is nothing happening in here for based on every month. Okay, so everything is happening in 6-month period. So that's why this is also 20 and this is also 20. Now the payment periods in month for this first case is 6. Okay, that means 6 months. Payment period in months. Let me just write it down. Okay, equal to that. Compounding period in months, this is also 6. Alright, for this case, what is happening? This is 6, we already know that, because every semi-annual period it is happening, and the compounding period in this case is 1 month. Then we are going to calculate the compounding frequency. In this case, in semi-annual, there is only one compounding frequency, because we are trying to find the cash flow in semi-annual period. So this is 1, and this will be basically 6, because 6-month compounding period in semi-annual there are 6 months. Okay, so the effective interest rate, okay, IA, which is equal to, we can basically use the function for this particular case. That is a nominal 8%. We have to reduce that, so we can basically divide this one by 2, sorry, which is 4% for this particular case. This is basically happening for 6-month compounding frequency, so we can use the effective interest rate. Effective interest rate equation, nominal rate is 8%. Now divide by 2, because I need to convert that first in semi-annual and then find the number of compounding frequency, which is 6 in this case. That gives you 4.07. Alright, so now we are going to calculate the semi-annual periods for 20 years, for 10 years. That means 20 semi-annual period. So let me just put it somewhere here so you can see. Semi-annual period, which is starting from 0, 1 all the way to 20. Okay, so basically 10 years. Okay, now the cash flow, what is happening in the cash flow? At the year 0, you're investing 3 million. So 3, 1, 2, 3, 4, 5, 6. So let me just put it a comma right here. And then after that, every 1 year, they are basically trying to put the 200,000 for the cost. Okay, so 200,000. That is happening at every end of 1 year. So this is basically end of 1 year. Okay, so let me just put that to 0 like that. I think you can bring it down like that. Oh, cannot. Let me just put to 0. I think this will do. Okay, so what we can find now using these 6-month annual worths, we need to convert that to the present worth. Okay, so to do that, find the present worth. We're going to have to use the NPV function. In this case, first the rate is 4%. The values will be, remember, starting from the all the way to bottom to the 1, then close the parenthesis plus the first one, which is this. For this one, the present worth will be exactly using the same thing. Let me just do again. NPV, in this case, your rate is 4.07, and the values are 1, 2 to the end, parenthesis closed, comma, the first cost. Sorry, plus the first cost, not the comma. Alright, so these are basically two different situations. Now, what else it has asked you to do? Find the semi-annual A value both by hand and by spreadsheet. So basically, you need to find that how much in monetary equivalent is happening every semi-annual, because the cost is happening in every year, so we need to bring it down to semi-annual. Okay, so that means we need to find the A annual worth and A for semi-annual. Okay, which is basically PMT. This is the rate. Number of period is 20. Present worth is this. Remember, we always use the negative value for the present worth to make everything positive. So it will be 318 and so on. So I can basically copy and paste it for this particular case. It will be 324 if we use the monthly compounding interest rate. If we use the semi-annual compounding interest rate, this will be basically the answer for A. Alright. So I'm going to post this solution in the exercise in the Canvas too. So you can basically compare the video as well as these equation that I put in the Excel. Alright, thank you very much for watching the lesson number 8. We are going to move to the lesson number 9, which is basically comparing present worth and annual worth analysis when you have multiple projects or multiple options. Thank you.